There are a few rules to the fishbowl. We will have 5 chairs. We need another one. 1 chair is always free. If you want to contribute, ask a question, make a comment, contradict somebody, start a fight, I don't know. Come here, sit on the empty chair, somebody else needs to get up, and then we'll kind of create a more organic panel than the usual ones. It's very important to participate because we believe that your experience is valuable. You are the ones who are working with real code, with real problems, and we want to hear from you. If you have problems, if you have questions, if you have answers, that's something really valuable. So don't hesitate to come up here. I know sometimes it's a bit, how to say, you may be a bit nervous to come here, but the reality is that you have a lot of valuable experience to share with us. The basic theme of the panel is about dealing with large code bases. How many of you are working with code bases that you define as large? Raise your hand. Okay. How many of these code bases are older than 10 years? Okay. So I think we have a lot of things to discuss.
What issues did I face? Of course, the code base was broken. You have to adapt your code to new techniques such as 11, 14, 17. And the question is how to evolve your code base. Yeah, that is a key issue you have. You will not start from the green field. You start from something existing and how you can improve it, how you can make it happen. This is a key issue for me.
I have worked in a large code base. It's called the C++ standard library. And we also already have all the issues of backward compatibility, support of different versions, and so on, and it's a nightmare. I think it's time to stop standardizing C++ and go to something totally different.
Large code bases. Don't sweat about making it bigger. You know, you've got 100 million lines of code. Yeah, another 1,000. Who cares, right? The other problem is as well, watch out for duplicated code. You think, oh, that looks the same as that. Let's extract it as a function. Yeah. There's always a subtle difference. Make sure you add test cases.
That reminds me of something I learned in large code bases. Redundancy is a good thing. Because to avoid redundancies, you create more interdependencies between different code parts. Because you refactor all the things out. And suddenly you learn that you really have a problem to remove some code of your code base. If you just copy and copy and copy and copy again the same code for slightly different cases, and you need one case, not anymore, you can remove it. Now you might say, the usual arguments of the people is, but then if I find a bug, then I fix it in only one location instead of all locations. And you know what the answer is? If you find the bug only in one of the cases and not in the others, that's a proof that it's not, that it doesn't matter in the other locations.
The thing I observed is that you find unique and different styles of writing C and C++ in a large code base which is old enough, so which came from C and was then transformed to C++. Most of the times I can't tell if the programmer started with C or with C++. It's still sometimes there. So that's my observation.
Okay. Anybody from the audience has any questions about or any solutions about or any issues on working with code bases? Otherwise, I'll just continue with the things I've thought about. Not enough courage yet. How about compilation time? Does any of you have a problem with compilation time for the large code bases? Okay. What is the compilation time for you? It's hours, days, half an hour, okay? 4 hours, okay. Somebody else? 1 day, okay. Can you do anything about this? I'm asking, I don't know the answers, don't look at me.
Change compiler to a faster compiler. Don't use modules.
Use fewer files. You can have package files.
Okay.
Together.
That helps you?
Of course. Yes. Big convolution units much faster than very few.
My goodness. Oh my goodness. We work a lot, by the way, in the standard committee to make compile time faster in C++. The problem is that a couple of features we introduced now are more and more moving runtime to compile time. So with templates, you saw an example where we then, as an answer, had fold expressions, but also with const expr. So, which is in principle a good thing. We now make the situation a lot worse over the time, and the new concept models, so the models feature that will come with C++ 20 will target that. It should become what we see, it should become better by a factor of 4 to 10, which is still not incredibly fast, but I mean, that means instead of 1 day, we have 3 hours, and that's better.
Yeah.
So the modules that will come in C++ 20. So do you think that, for instance, we have like 2,000 DLLs, and each DLL, a library, and each DLL is hundreds of classes. It's not for free. I mean, who in the audience thinks that a code base 30 years old will be adapted to modules? Sorry? Pigs will fly, yeah? Before that. Yeah. So probably the modules will only be applicable to, I don't know, complete new code bases, compute new libraries, separate stuff, because you will also need, how should I put it, different compilation infrastructure for them.
I can answer that. First of all, we don't have many experience, and one reason we were hesitating to accept modules in C++ 20 was that we don't have the infrastructure for the tooling we need for modules yet. That the decision to adopt modules now in C++ 20 was mainly driven by the fact that no compiler vendor would honestly invest on a big tooling environment for modules unless they know that this is a sustainable development. So the main reason we have modules in C++ 20 is that we agree that we want to use them in future. And it's intentional that, for example, we don't deal, for example, with the standard library in a modular fashion. We have to reorganize the whole C++ standard library to make it really modular. And that's something that other projects have to do to come up with better dependencies than before. So I agree with you. We have, though, some experience reports by people using the experimental parts of the libraries, and we see these numbers. One major company, I think it's okay to say that, is Google, who refactored the whole code base. They do a lot of with C++, because with Java it would cost 10 times of the energy to run all the computers. And so in the past 10 years, no, not 10, 6 years, they reorganized their code base based on that, and they demonstrated some numbers that look like that. But we have to make this publicly available. Google has a lot of resources which other companies don't have, so this has to become part of the tool chain. And then I would say in C++ 23 we have enough experience that we, for example, know the rules how to use models, we have the tooling available, and that we can use it. Yes, so it's standardization is still a long time. Don't expect a miracle there.
Okay, so maybe an interesting question related.
Can I kick in?
Please.
I'm a little bit curious about concepts. How expensive are concepts? Because in C++ 11 they were kicked out because of compile time, as far as I know. What's about 20? The concepts implementation 20, will the compile time significantly increase? Are there any numbers so far? I like the feature, but I don't know. Okay.
I mean, concepts you can use concepts right now already with enable if, and to some extent this is only using a better syntax for that. And yes, but we create more effort on the compile time, with each and every of these features, so we will become slower. It's not that nasty, I think, otherwise the community would kill us already.
Okay, so an interesting question then, because of this. We are talking about C++ 17, 20, 23, but how many of you still use code bases that are older than C++ 11? Anybody still using 98 or something? Okay, so still a few. So maybe an interesting question is how can we switch? So another challenge is switching to the new versions of C++, the new standards. Maybe you have something to comment.
Visual C++ has changed its policy, and they try now to be even more backward compatible than before. I talk about binary backward compatibility, and in the API we try to be backward compatible all the time, but that might mean that we have to recompile the whole code. ABI compatibility is something we not officially have in C++. We consider this to be in the goal. And the Visual C++ 17 was the first compiler, major compiler version, which was backward compatible to Visual C++ of C++ 14. They will probably have a problem to make that again with C++ 20, but let's see.
In my experience, it's not always that easy. Just because you are lucky enough to can switch your compiler to the newest version, it doesn't mean that you get all the tooling. So I'm talking about static analyzers, for example. So I made very bad experiences when I finally had a compiler able to compile C++ 11, but no static analyzer really understanding C++ 11. Some jumped out early and produced an awful lot of errors. Others just skipped the statements they didn't understand, which is not helpful at all. So it's not just upgrading the compiler and your code base, it's also the tooling around it.
Major merchant banks very rarely update their compiler. Normally you just get an increase in legacy. So you've got GCC 447, GCC 402, and you've got header files for each, and you just end up creating more. The old stuff isn't updated because of production. You may have older operating systems there, usually prehistoric. An inadequate knowledge of the CPUs and OSs. So most merchant banks, when they release a product, you have some kind of person I'll politely refer to as IT infrastructure, And they tell us what compiler we have to use because they have no idea. And I'm being very polite about it. Frankly, I think they should be, to quote Death of Stalin, taken out and bulldozed into a lime pit out the back. But the problem is you have this increased legacy, and it doesn't help when you have operating systems, Red Hat, I'm looking at you, which have newer versions of compiler but older ABIs. So you have abominations like C++17 with the old C++ ABI.
How about preserving existing features? So we want to update our code, but then we get into this trouble of, it still has to work like it worked 20 years ago or better. How do we do that?
See if you can hear the trader screaming.
Okay.
Test cases.
Good plug. How do you deal with this in the audience? Or have you ever dealt with this?
Persuade them that the previous feature was a bug.
That's a fun one.
What's new in this version? New bugs. Yeah. We have it. Yeah. Yeah.
So any fast ways of checking the existing behavior of systems?
Test.
Use different compilers. That's for me the easiest way to check your code. Follow each warning. Follow each warning. Yeah, you should read it. That's the reason.
Okay, in one big project, we had the following side task. Every 2 weeks, a new compiler warning was enabled. And then a team of 2 or 3 people just tried to fix them and find out whether this warning was a serious issue or not. And it took a couple of years because, at least with GCC, there are a lot compiler warnings, and not all of them are non-serious, should say.
Don't run C++
Don't run C++.
filters. If you use Unix, don't run C++ filters. War story. I worked at a bank which will remain nameless. The technical architect who shall remain nameless. He decided it was a good idea to enable all warnings. But the problem was he didn't like the gigabytes of warnings that were produced because that slowed the compilation time to write it to disk. So he piped it to grep, C++ filter to grep. And -v, and cut out. So there were very few warnings. It was great. Yeah? Don't open the door and see the monster behind. How many bugs were there in the code? It worked by accident. I work at another merchant bank. Warnings. They, in global namespace, all their classes begin with a leading underscore and a capital letter. Yeah, genius, hey? Their entire code base runs by luck. Compiles and runs. I've seen the code. I wrote some.
Right. So any other practices that might help with large code bases? Well, things that you've done in the past, or any other questions? We are here now, so we might as well benefit from...
Delete the coding standard. If you've got one, delete it. Yeah. The coding standard at this major merchant bank said, Rule 1, all global namespace identifiers must begin with a leading underscore and a capital letter. How do you improve the code quality? Delete the coding standard.
Your coding standard.
Delete the bad coding standards. Oh. Yeah. It's It's, by the way, that's an interesting thing. I think we don't have enough coding standards right now, because the problem is C++ has reached a complexity that's no longer maintainable for an individual programmer. So think about the initialization example I gave. So when I started for a new training program for mobile automotive company, we thought about what should we teach how to initialize an object, which created some interesting discussions. It turns out that we have a problem right now in the community to fix the complexity monster we have now in C++. We need style guides. But we have different style guide approaches and they contradict each other. So for
Style guide must be updated. It's a live document. This is what the bank forgot.
yeah, but the problem is our style guide leader in the community has retired, which is Scott Myers. So we have no longer anybody ruling our C++ world. So we have a problem.
I thought Bjarne came up with something called, what was it, that C++
Core guidelines?
core guidelines.
Yeah,
And
they are good unless they teach something wrong.
you see, there's the problem.
Yes.
Right? We've got two leading figures in the community who disagree with each other. Throw away the coding standard. Yeah? Liberate yourselves.
Some areas.
Don't sweat the small stuff. Where you stick braces is not relevant, really, honestly. I've seen code where the file had the braces in different places because it had 6 different styles. In the end, I just gave up.
To be honest, there are different style guides. For example, Mr. C++ or AutoSAR, they are extremely special. Extremely. But C++,
is safety critical.
but it's from 228, so it's not the way we write now code.
Well, AutoSAR is pretty good, to be
AutoSAR
honest.
is based on 14. It's quite good, but it's also something which is standardized, so it will become old-fashioned in a few years. I assume it at least. I'm more with the C++ core guidelines. The point is not to follow the core guidelines, but to open your brain and think about the guidelines.
Yeah, and that needs time. And for time and refactoring, you need time in your projects, and we don't have that in the projects. So switch to Python.
Yeah, of course I can give a Python seminar.
Yeah, unless you're interested in performance, and then talk.
So.
Performance. Well, come to my you come to my talk at the end and you'll hear about performance.
Okay, any questions? Let's see. You can also ask questions about an unrelated topic to large code bases.
Maybe even more stuff about compile times.
Yeah.
I'm sure there are a lot of tricks in here.
High time trick.
Yes.
Let's talk about that.
No,
yeah.
I mean compile times. Time takes to compile a program. We talked a lot about templates, for example, and it takes a lot of time during the compilation phase. We didn't talk about optimizations and how much time they take. I don't know about the other compilers, but in Clang you can have a very nice profile, and you can see how long each optimization actually took to do, and that can really be some low-hanging fruits there. You can have a look at it and see if there's something strange in some really old source file that no one has touched, and it's structured in a way that makes the compiler really, or the optimizer really stretch and take long times.
Okay, one thing you should know is external templates. Who knows external templates? Oh, not many. It's a way, but because usually compiler templates kill the usual compiler linker separation, because where you use a template, you need the implementation, and you compile the template for your usage, because then the types are clear. And with external templates, you can say for a certain amount of instantiations, I want to have a pre-compiled version, or I have a separately compiled version in its own translation unit. For example, a couple of code bases do this for string, basic string. A string is, the type string is a template. It's templified, for example, for the character type. And it makes no sense that each and every compilation unit compiles the whole string code again and again and again. So instead you would have provide one translation unit with basic string for compiled, and then you would use template just the usual way you learned them, with declarations separated from implementation. So if you haven't heard about that, look at extern templates. That's a feature that came with C++11, and that can save a lot of compilation time.
Low-hanging fruit. How many people came across their installation at work where temp was on a network file system? So all the temporary files written by GCC took forever? Yeah, just saying no. Other obvious things. If you've got many, many gigabytes of RAM, Unity builds can help. That's one possibility if you can't have modules. Other things as well. Check your includes. Remember, the includes touch the disk. I've come across places where the header guards were curiously placed, where the coding standard said that the includes should be outside the header guard. So the contents of the file was in the header guard, but the hash include files were above the header guard, which meant, of course, you touch the disk all the time. Which is, if it's a network file system, very slow. I mean, okay, there's NFS caches and so on, but even so, if you've got a very large project, it floods it straight away. Again, a lot of people bring in the kitchen sink with the header files. Please don't. I've had great success in speeding up compile times by just deleting useless header files.
Just wanted to ask, aren't all header files useless? No, just kidding.
Unity build, hey, everything's a header file apart from one.
Just out of curiosity, are there any other ways of splitting a big code base into smaller pieces in C++? So we talked about modules. Any other?
Come on, I'm not going to say libraries. That's so old school.
Well, we still have 10 minutes left, so if you don't have any questions.
All problems are solved already. Huh?
Yeah. There's no more issue with, please.
So how do you upgrade your humans, your actual programmers, to the new standards? Because you might have like several people on the team. Yes, the gun is one option.
Any ideas here?
Trainings,
Yeah. Well, I can speak.
code reviews.
Yeah.
By the way, there's something that a lot of people didn't understand, which is it's not the goal of code reviews that the expert reviews the novice. It's also important to make it the other way around, so that the expert learns from the novice when he or she writes code nobody understands. And we had projects where we fired the best programmer from the project because he wrote code that was not maintainable.
Yeah. So I can answer part of this question because from our experience, there's a whole different skill of changing the culture of a team from upgrading to technology. And usually what you need to do is to look at people who are excited to change. And that's a very common pattern. Start with them and then kind of spread this around through trainings, coaching, pair programming, code reviews, whatever. This is one thing that works very well. There are more patterns here, and if you are interested in changing organization, there's a really good book by Linda Rising called Fearless Change that gives you a lot of patterns for doing that. Well, this is more of a cultural thing.
The biggest problem I have faced, and I'm sure many of you have faced, is I forget the name of the law, but it's people don't know what they don't know. So therefore, I remember when I started coding, I didn't meet other people, I worked by myself, and I thought I was a genius in C++. I was a moron. Because what happened is a friend of mine told me about an organization in the UK. You can find it on LinkedIn and so forth, on my profile. Now, what that did is I then met people equivalent to yourselves, a vast array with a huge array of skills. The point is tell people. At work, I'm sure you've got colleagues who display more or less interest in programming. But tell them about organizations like this, about training programs, etc., and how good it is, and in code reviews, point out, oh, I learned this from this conference. I'm not advertising the conference, I'm saying to these people, make it obvious to them, make it easy, put a link in the code review so they can click on it. Yeah? Sugar the pill. This is very useful. For example, at a major merchant bank I worked at, I regularly give talks, and what I did is I just said, there's a lot of people here who don't know. I'll repeat the talk at the bank for free to distribute and disseminate the knowledge. And hopefully a few people will wake up and actually upskill themselves, realize that they should move out of this little bubble.
Who here knows the Yagni principle? Okay. That's an acronym for you ain't gonna need it.
OUXP, are you?
No, it's XP maybe. No, and the issue is if you have a large code base, don't solve all the problems in a head you might get in future, but you probably will not get. And by the way, we have done the same mistake in the C++ standard a couple of times. We have a nightmare introduced in the standard which is called vector bool, because we thought it's a cool thing to specialize a vector for bool, and it only creates nightmares one after the other. And another example is standard string, so std string, is parameterized for the basic character optimizations, the so-called character traits. We think this is a mistake. We thought it is a good idea, and it turned out nobody needs it. And we carry this weight with us now for 20 years or more. Valerie, the good thing with Valerie is something you don't use, but it has no influence on the other thing. The problem with string is used by everybody, so you use this extensional design and flexibility all the time. You pay for it all the time without having any benefit. And the same is true for vector bool. We have a couple of rules dealing with vectors where we have problems with iterators, for example, because they can be proxy classes instead of pointers, etc. So these are the bigger mistakes where we thought flexibility is good.
What about IO streams, facets?
IO stream facets is the same thing. We have in C++ 17 partially removed facets. Okay. We introduced in C++ 11. So yeah. And
okay.
By the way, what is can I just say that? What is the most important biggest thing that will come with C++ 20? The best feature ever. Ranges, coroutines, modules. No, you're all wrong. The most important feature is UTF-8 support. Finally, even C++ supports UTF-8. Oh. Wow.
Yes.
Maybe you should switch to Python.
Okay, so
no,
we
I speak for both languages.
we have just a few minutes left, so any closing remarks?
Avoid unnecessary generosity. Angle brackets are good.
Okay, so we learned about removing the guidelines and removing header files and using modules and Just a quick recap. So it's time for our next coffee break where you can approach the speakers about these questions as well. Thank you.